Welcome to ACME Shed and part 2 of making a 5/8 5 TPI right hand ACME tandem unipass tap to cut a new bronze nut for this lead screw from the saddle of my Herbert Junior surface grinder Mark II. It's hard to say all that without fluffing. Enjoy. In part 1 we made this experimental prototype out of Delrin. In this part I spent quite a lot of time deciding how best to cut the flutes, and once I'd got a solution to that I cut them, and then we put the tap back on the lathe and I machined the tapers. This is a lot of work for something that could end up as trash. I've used a 7mm end mill to cut a 3mm deep pocket, and then we'll try that shaped end mill, the ball end one. Now this may be too wide. I just happen to have a very sharp, new in box, 7mm end mill. I think maybe a 5 would be better. You know, I'm not really getting anywhere with this at all. Maybe I should just buy the tap. This looks alright. This, you know, using that ball end mill, yes, I sort of widened it, but look at the burr on it. So that's blunt as blunt. That's no good. I could have cut a much narrower channel, and if I'd had a sharp tool I think that would have given me this sort of shape. But these are only this sort of shape because they're ground this way as far as I can tell. But one thing I've still not thought about, I don't have a plan for, and that is these have a rake on them as well. So if we were to look at this from the end, I don't know if that's possible, let's try. Yeah. Goodbye. Right. Yeah, you can see they've got a rake. I still can't tell if that's focusing. There, it's focused. Right, you can see it's actually got a rake because it's ground off. It's high here, wherever here is, and it's low at this side. So I'd have to find a way of putting a rake on it, I suppose. Although I did see a channel, people making taps, and they didn't put a rake on it, trying to make the same sort of tap as I am. Next day, fresh brain. This ball end cutter, I thought, well, there's nothing to lose, why not try and sharpen it? And I took it to the grinder and just sharpened the edges, and now it seems to work pretty well. Oh look, has it been 5 minutes already? And it's cutting pretty well. Well, this is where we are now, and the quality of this finish is pretty good on both sides. And it's amazing to think that was just a very quick touch on each of these two lands with the grinder, just by eye. This is looking pretty tap-like now, if you forget this one here. But you can see the edge, which would be, this one would be the leading edge if it was a right hand. It's not even 90 degrees to this edge, it's more sort of tipped up this way. So I'm thinking I need to adjust the position of the tool, and probably, I need to think about it, but I'll take the tool off center so that it's cutting much higher up the edge at one side here. I've machined this, by the way, so that is about 5/8, and that dimension there is about the finished dimension. Let's say that one there is about the finished dimension. So you know, confidence is increasing again. After yesterday evening my confidence was kind of on the floor. Well, I think this is about my 4th or 5th prototype now. I'm just doing the last of the 4 flutes on this one. This mill is running wonderfully. Last cut, last flute. Right, here's the evolution. So these two, I was trying to cut flutes with this ball end mill after I'd sharpened it. Once I'd sharpened it, it was working pretty well. And this one is where the ball end mill centre line is on the same centre line as the workpiece. And it looks pretty good actually, I think. Forget that one there where I was trying something else. And I think it looks pretty good. I don't know if that's going to focus for you. But the problem is that if you look at the angle which is approaching this edge where the tooth would be, cutting edge would be, that angle is more than 90, which is going to make it drag more than cut. So although it looks nice, it wasn't going to work. So then I tried moving the tool offset. So I thought, well, let's try and get a steeper edge against this tooth. I'm going to call this a tooth. Against the tooth. Well, I ended up with this one, which would have been better left hand. But you can maybe see, I'll show you anyway. So I moved it over here and I was cutting more like that, look. Okay, so the point, although it's not a point, was just there at this edge. And that gave me quite a good angle. So if I'd been cutting left hand, because that's how it worked out, that would have given me a good rake on that edge. But the problem is then, because it's curved, as I was to taper this, the rake would change. And when this was at its narrowest, the rake would have been more than 90, so it would have been dragging. Now that's what taps are like, when you look at these here. But they seem to grind them so far in that it doesn't have much effect. But it's a U shape, and you can see how eventually, like it is there really, the rake is going to change. So, because my thread's teeth are so deep, I didn't want to use that shape, that form. So I started just by cutting into the edge, and I tried it a number of different ways before I figured out what I needed to do. And eventually I came to this, which you just saw me machining, and that, I think, is going to work. Now, if we look into it, on this line, vertical, it gives the appearance that that angle is less than 90, which is what you want to give you a cutting edge. And then we can taper this all the way down, and it'll still have that, keep that same angle. That's the plan anyway. So I'm pleased with that. I think that's going to be my final design. I cut in 3mm from the peak here, and it was off centre by 0.5 millimetre this side. So the edge of my tool came in to the centre line, and then I added 0.5 millimetre. I'll just show you something on a drawing which I think reinforces that point about the cutting angle. So if I cut up to the centre line there, that gives me 90 degrees here. If I cut a bit further over like that, which is what I've done, and draw a line through that there, like that, well, you can't really see now, but that angle here is now less than 90, which is going to give me the cutting edge that I want. Let's take it extreme so it's easier to see. So I've gone right over to there, put a line through that, look. Oh, that was rubbish, that line. And look, that now looks like a tooth coming out. I'm just doing a few more tests. I've made up this little plug here, so it's 5/8 on the outside, it's about 10.5 millimeters in the centre. I've put the tailstock in because I want to see what clearances I'm going to get. I'm using a 1/2 centre here. This is only mild steel, but I want to see what depth of cut I can get. I think probably 0.1 of a mil would be too much, that's 4 thou. I think we're going to be on a 2 thou cycle, but we'll have a look and see. I'm only running this at 75 RPM. It could run faster, but it moves along here so quickly. I just want a bit of time to give me some control. This will be about a 4 thou cut, 0.1 of a millimetre. Let's see how it copes. Okay, I'll do a few more of those off camera because I really need to concentrate on what I'm doing. Well, I did 5 cuts at 0.1, but then the last 2 cuts I did at 0.05, so 2 thou if you like. Because I think as it gets deeper and the cut gets wider, the strain would be a bit too much. It's getting slightly ragged anyway, but it's only mild steel. You'd kind of expect that. So that's looking okay. I thought I'd try this, but interrupted cuts are not great. So I think we'll have to cut the flutes after I've cut the threads. When I made my Delrin test tap, I made it that way around. But this time I'm going to make it that way around. And the reason is that I want to be able to do some test cuts at this end. And I've made a Delrin nut as a test piece. So this part, the roughing out part of the tap, I'm going to leave the same size. But the finishing part of the tap, I'm actually going to make this threaded part longer. And that's because, too many hands here, look. The full size part of that threaded part ends about there. And there wouldn't really have been enough, I'll do it this way, look. There wouldn't have been enough sticking out to put the square on. So I'm making this a bit longer. Okay, so I need a relief here so that when I'm reducing this part to make the roughing part of the tap, and I'm making the threads narrower, I'm only going to cut this section, not this section, so I just need a relief here so I can stop. So that's the first step, or the next step, is to cut those reliefs. End of prototyping, so now we get on with the real thing. This is the order of events. Cut the reliefs, cut the thread, cut the tapers, cut the flutes, cut the square, the driving square on the tap, do a test cut on this Delrin nut that I've made, trim the threads if I need to. When I'm ready, harden, then temper. Easy. Well, you can see I've cut the reliefs. Now this material is quite tough, so I'm certain I won't be able to cut the threads at more than 2 thou per cut per pass, 0.05 millimeters. But this was made easy, cutting these reliefs was made easy with this new parting tool. Now it's not really new, I've had it quite a long time, but I was waiting for it to make an appearance on the channel, and you can see PWT tools written upside down there, but to fit this. So it's not an extender block that clamps into a tool holder, it's all integrated, the whole thing. It's a 2mm blade with an insert. Well, as you can imagine, it was quite expensive, but I couldn't live the rest of my life in fear of parting off. So I went the whole way and bought the integrated tool. Now, he gets them from Peter, his name is Peter. He gets them from China, but to his own specification, but they didn't have any in stock. I had to wait until the stock came into Hamburg in a container, and then pretty quickly they got them shipped out. And I managed to get it for just a bit under the customs limit, so that it didn't attract customs duty. But you've got to be really careful about that now, post-Brexit. It can get very expensive. So I bought the inserts from the UK, even though I bought the blade. The blade probably looks like any blade you can get, but I thought, let's, make sure it's a quality blade. Turn it that way up, you can read it then. Let's make sure I get a quality blade, as I'm spending so much money on a quality holder. But by buying the insert in the UK, I just kept the costs down enough to avoid the new import duties. Next day, and I've got a couple of clear hours, so I should be able to get through cutting this without any interruptions. I'll need to do 50 cycles at 2 thou per cut, 0.05 millimeters, cutting down to 0.1 of an inch tooth depth, thread depth. Now there's 7 operations in each cycle, so I mean, put the cut on, that's 1, turn the machine on, that's 2, stop the machine, that's 3. So 7 per cycle, 50 cycles, that's 350 individual operations, keeping concentration all the time, If I mess any up, it'll probably mess up this job. And then on top of that, I've already made sure that this back edge of the cross slide is going to clear the front shoulder of this tailstock. Struggling for words at the minute. It must be because it's a bit chilly. So that's going to clear, and this is a dead center, but with like a half dead center. So this will clear this, but I've still got to be careful because the fixed steady could hit this dead center. There, it's hit it now. So I can't allow this to come much off the work before I stop it. Somewhere like that. Got to pay attention. So I'm going to do this off camera because you wouldn't think it would be possible, but actually just thinking about the camera is quite a big distraction. So maybe I'll do the first cut on camera, after that off camera. Okay, show's over now until I finish this. Right, this is 2/3 of the way there. I've done 20 cuts at 2 thou. That's 40 thou. So that will be 1 millimeter depth of cut when I pull this lever over. Okay, this is the 20th cut. Just checking, yes. Right, well, we're close. This just goes on, so it'll need a bit more off yet. It binds around here, but I had a bit of a scare because when I was cutting a couple of cuts ago, I had a dig in. It bound either side, it lifted up, it pushed the fixed steady pins out a bit, and the tailstock moved back fractionally. So I just caught it, I just saw it going, and I stopped the lathe immediately and then wound out the cross slide. And I think the conclusion I've come to is cutting straight in to something like silver steel is too much. So I've backed off to 1 thou cuts now just to do the finishing. I just need this nut to be a little bit sloppy. It's too tight there. The reason I've gone straight in is I'm going to have to put some feed on to make that into a roughing tap here. I'm going to have to put some feed on there. You can't see what I'm pointing to, but you got the idea. On the top slide, it's come out, there you go. I have to put some feed on that top slide a bit that way to thin these teeth off, threads off, to make this into a roughing tap. And if I'd got the top slide over here, you know, 14.5 degrees away from straight across, it would have made it a lot easier to cut these threads that depth, but then I'd have to pick up on the thread again, set the top slide to this position to narrow these off. I hope you're following all that. So yeah, might be fine in bronze to do it like that, straight in at that depth, but unfortunately I've lost a bit of the sides of the tooth further up here somewhere, around this corner maybe. It won't matter, but it was a hell of a scare. We're down to the last few trimmings now. So if I measure that wire on the original lead screw, I'm measuring there 16.5 millimeters. When I put it on the workpiece, I measure 16.7. So obviously the difference is 0.2 millimeters, but because the sides of the thread are so steep, that's only a fraction to come off. And at the same time, same measurement as I've just shown you, that's going on there very nicely. And if we weren't cutting this, then we would say that was great. But if I cut into this at this will still be too slack when I cut the new one on the existing lead screw. It makes sense, I hope. So what I need to do is to cut this a bit more to make this quite slack, like it was on the original lead screw. But when I do the wire test, the measurement across there has got to be a little bit more than on the original lead screw to give some clearance between the new nut and the original lead screw. If I do this, maybe it'll look a bit more serious. So now we're at the point where I need to give it a scrape, measure, give it a scrape, measure. Right, I'm on my third scrape, third pass at 2.7 millimeters cut, which is that much in inches. Now, by my calculations, the thread depth should be 0.1 of an inch plus a bit of clearance. So I think this is going to do it. It's all set up. Let's not mess it up at this late stage. No, I'm just checking around. Everything's go. Actually, I'll just put a bit of oil on it. So there's no extra cut. It's just a spring back pass, if you like to call it that. This may be it. Whoa! Forgot to reverse the lathe. I think we're there with this. It's a little bit on the slack side, but it's not quite as slack as it is on the original lead screw. Now I've given up the idea of cutting the flutes now and then attempting to cut the Delrin nut, doing any final trimming on the threads and moving on from that. I'm just going to reduce this part now to make it into the roughing out part. There's too much risk in swapping things in and out. I've had a few scares with this already, so I think we'll just settle for this and just that'll be it. So I will now use the top slide to add a bit either side of these threads just to make this the roughing part, and then we'll reduce the diameter slightly and we'll be putting the tapers on. So this will be the roughing part, and it's got a good old wobble on it and slack, rocks, that's good. This part will be the finishing part. Still got a bit of slack on it because we want it like that, because we want to make a tighter nut. I would have liked to have made these teeth threads a bit thinner. It just wasn't working out that way. I was adding side feed, but it just didn't seem to be taking off as much as I thought it should. But when you look at them, well, the crests do look narrower and the valleys do look wider. So there's some effect of it. And then of course we're going to reduce the diameter as well. So I think it'll be okay for roughing. Well, next day, and I was going to start by cutting these tapers here and here, and I could do it with the top slide, but I wanted to leave the screw cutting gears engaged, so if I had to come back and cut any more off these threads, everything would still be in registration. Now, because it's quite a coarse thread, I think now with a bit of experience I could probably pick up these threads quite easily, but I'm a great believer in not changing anything until you have to. So I'm actually going to mill these flutes now. It does mean I'll be milling material which I'm later going to take off in these tapers. So a bit of a waste of time in that sense, but it does actually mean I can put this back on here and I can try to cut that Delrin, probably with this still full size. Yes, with it still full diameter. But we'll see if the Delrin will cut. So now we're off to the mill. Well, we're nearly out of real estate. It's end to end on this bed. And keeping this work in this chuck is ultra cautious. But you don't know, do you? Best not give it up unless I have to. Anyway, the run out on here is about 6 thou or 0.15 millimeters. So to be honest, that's near enough for what we're doing here, which is just cutting the flutes. And in fact there's a little bit of this on there, look, so some of that is me pulling on it. It'll do. Now you can see where the tool dug in, just there, look. Took the side off the thread, but we'll lose most of that when we put the taper on, so it won't matter. I've touched off here and we're going to be cutting 3 mil deep, 1/2 mil over centre towards us. So we'll start from this end, so we're not climb milling. I don't know what the opposite of climb milling is. Scoop milling? I don't know. Maybe you know. We'll put on a 1/2 mil cut, which I can't do because the tripod's in the way. Let's try. Yeah, 1/2 mil cut. Okay. Get it in the right gear. Turn it on at the wall. Yep. Dare I do this with the camera on, because I usually screw up. It's not too cold today. It's about 9 Celsius. I meant to put a jack under it. I need to jack this. Actually, I've got a better idea than a jack. If I clamp that down and put something through there, maybe 2 if I can find 2 appropriate nuts or something, and that could support it most of the way along. I think we're going to have just enough bed. It's pretty close before we run out of travel. We've just got enough. Probably 1/2 inch to spare. It should stop automatically, but I'm not going to risk it. That's 2 done. Final cut, 3rd flute. You can see I've changed the supporting bracket there. Last flute, last cut. Hurrah! That took a while. Oops, radio's on. Alexa, mute. Don't want a copyright strike, do we? This is warm, but it's not over warm at all. It's fine. This lathe, in fact, it's not a lathe, it's a mill. This mill is running really sweetly now. Well, it took a long time to get this mill sorted out, didn't it? I think there was a series of 11 parts just on the main mill, and then from memory there might have been 5 parts just trying to get this head right. I think the last one I did was just adjusting the bearings, but there were many parts working on oil leaks and so on. But now it seems to be running very sweetly, including the new table nut as well. Maybe I'll look at adjusting the backlash on that shortly, because it should have bedded in by now. So we get this bracket off and see what we've got then. Is it better this way or that way? That way, perhaps. I need to get some more T-nuts. All I've got there is the head of a bolt holding that down, an upturned bolt. And before you say it, no, I don't want to make any. Although, actually, I could do it with a horizontal mill and gang cutters, couldn't I? That would be quite fun. Ooh, that's not wanting to move. Why doesn't that want to move? Let's try this. There we are. Ugh. Everything is awkward. Took me about an hour to set this thing up. That's why, because it was in the T-slot. I think every one of these teeth is going to have to be dressed by hand, because there's burrs on it all over the place. Yes, it looks impressive. I hope it's going to work. Right, back to the lathe. I think it's time to give up on the thread registration, and if I need to cut the threads a bit more, I'll just pick them up. So we can get the taper done now. The last thing I'm going to do is to cut the square on the end to drive the tap, because that's going to reduce the diameter quite a bit. It's 10.5 at the moment here, and I guess by the time I put a square on it, it'll probably be, just guessing now, 8 across the flats. So that makes it quite narrow. When the taper's on, then I'll reduce this part here, this diameter here. The two tapers are done. I'm sporting this in the centre with the fixed steady, and I need to decide how much to take off the diameter here. Now, the tooth depth, thread depth, is 2.6 millimeters, near enough. So what do you think? 1/2 mil? Will that be enough? We'll try 1/2 mil and see where we get to. Right, wind that off the taper, check it. Looks all right to me. Start it. I haven't put a cut on yet, have I? I'll put on 0.2 mil because this tends to chatter. Just check it again. Check, check, check. Yes, that's all right. I went to 3/4 mil in the end. Yeah, so you can see that's a bit wider than that. I think it gives, you know, it balances it a bit between that and that. That's all I can say. So I'll clean that up. I'm going to try, see if we can cut a bit of Delrin with it. Well, we've got a bit of a problem. I'm trying to put the threads onto this Delrin. It's not working very well. What's happening is the Delrin is really getting stuck and jammed on the tap. And I think part of the problem is there's not enough space for the shavings to go, and it's kind of jamming it up. Also, the Delrin is inclined to spin on the spot rather than pull itself onto the tap because it's too difficult. So I need to think about it. What I could do perhaps is harden and temper it, put the surface grinder back together with the old nut, and then grind along these relief channels, make them deeper. At the same time, that would sharpen up the teeth on the tap. Another idea is to thin out the threads on the start part of the tap, on the roughing part of the tap, and that might act more like a screw helping to pull the Delrin on. So I've got to give this some thought. It's getting dark, it's time for tea, so we'll see what tomorrow brings. Well, since the last report, I've narrowed the teeth on the roughing part of the tap. I looked online and they're quite spiky pointy online. Well, I've just taken the corners off to make it a bit easier for roughing. But it wasn't going to help me at this part, the starting part of the tap, because by the time that you've narrowed off these teeth, by the time you get to the end of the taper, you're just down to the root of it, and it doesn't make any difference. I hope that makes sense. Anyway, I'm going to try cutting a thread in this potato and see what happens. I've just got to cut something soon, I thought about cheese, but I think cheese is probably a bit too soft. Sounds like a joke, doesn't it? But I am serious about this. I'll see if this potato threads on to the lead screw then. Just bear with me while I do this. It's a bit of an ugly potato, but I think it'll be okay. Now I do have a plan if this works. I've got to test this on the lead screw. I can't do any more work without some idea if this tap's going to be any good. Well, we've got through the roughing part okay. Now we start on the new taper. Why am I giving a commentary on a potato on a tap? For God's sake. I'm losing my mind. Right, now we're into the meat of it here. Oh, it's feeling good. Oh man. Wow. Right, well that was very satisfying. Okay, I'll wind that off and we'll try the potato on the lead screw. Sounds like an absolute comedy, doesn't it? But I'm serious. I'm trying to think of potato jokes. I can't think of any worth saying. I'll just have to be careful not to cross-thread it. Oh dear. It's not proof of much, is it really? The potato's binding a little bit. Well, it was fun. I guess the potato just expands. You know, as I try and cut it, it's yielding, isn't it? And it's slightly elastic. Why am I discussing this? Right, okay. Yeah, okay, well, that's proved not much because the potato's a bit too soft. It's a good thread in there. I don't suppose you can see that really. Oh, there you go. Well, the next thing on this will be to part it off and cut the square on the end. I mean, it may be that the bronze would perform better than this Delrin because the Delrin's inclined to skid and rather than cut and bite. But I'm going to use this tool here. You can see it's just a tiny point on it. Oops. And I'm going to bore into that, thread into that is what I mean. The width of the end of that tool is about the same as the width of the root of the thread we're trying to cut, so that would take a fair bit of it out. But it only just goes in. I'm going to have to grind the back of this off here. It'll just go in, and then I'm going to have to advance this tool in this holder to put the cut on. But again, we'll just experiment and see. I may come up with a better idea later, but I just want to see if I can chase out a lot of the material just like this.